We have some box plots here to start. Now it's very important we can read off the 5-number summary in these box plots. Using distribution B, we have the min, which is an outlier. We have Q1 right here, which is very high, the median, which is the highest median, Q3, and the max. Now this is kind of a unique one because there's nothing kind of normal low. It doesn't have a whisker in the box plot. And this is possible. All the data is just tightly clustered in here. These are what we generally see when we see box plots, but we need to make sure we can understand any sort of box plot. Going over here to A, we have the min, Q1, median, Q3, and max in that order. So which vineyard has the most expensive grapes? Well, that would be A, because of the max for A. Also, be careful. A lot of times they reorder these, so watch out. It won't always be in ABC order. Which vineyard produces the cheapest grapes? Well, that's also A. They have the cheapest. Which vineyard are the grapes generally more expensive? Now, take a look. 50% of the grapes for vineyard B are right here at the median or above. 75% are at Q1 or above. And that doesn't even come close to these other ones, because right here is where the 50% is and the 50% there. So with 75% of grapes being more than 110, 115 is definitely vineyard B that has the most expensive grapes generally. Determine which sentences best describe which vineyard. Considering that vineyard B is the only one with an outlier, that would be statement 3 describing vineyard B. So now we're down to these middle two right here. I see a difference between statement 2. Statement 2 states, this vineyard has the most variable case prices. And looking between A and C, A has the most variation. So definitely, most variation is for A. Going on to the next problem, we have the 5-number summary. This is not the data. So which group had the highest score? Just looking at the data, we can see the max for boys, which is the highest. Which group had the greatest range? To do this, we need to do max minus min. And in my example right here, the min is the same for both. If we do max minus min for girls, we will get 3.4. That is obtained by 5.7 minus 2.3. Now, to do it for boys, we would do 5.8 minus 2.3. If you notice, since the max is further away, the boys will definitely have the greatest range here. Which group had the greatest interquartile range? Interquartile range is noted as the difference from Q1 to Q3. So with this in mind, looking at the boys, we see 4.9 minus 3.6. We should get 1.3. Now, with 1.3 in our head for boys, we can go over to girls and do 4.8 minus 3.4. That's because this is Q1 and Q3. Remember, this is a 5-number summary. We will get 1.4, which means for girls, they have the greatest interquartile range of these two data sets. Which group scores appear to be more skewed? Now, the way they look at this, which we don't mention that much, is there a greater difference between one quartile to another? And let me explain in greater detail. To answer this question, look at the median. Now, take the distance to the next quartile above and the next quartile below. If you notice, the median is 4.1. Now, the distance to 4.8 is 0.7. The distance down to 3.4 is also 0.7. You might have to subtract them out to get the difference on a calculator, but we can look at how much do we have to add here and how much do we have to subtract here. This one is symmetric. Now, going over to the boys distribution, to the right is 0.7 again, but to the left is only 0.6. This indicates a slight skew. So we can go ahead and answer that boys are just a little bit more skewed. This question isn't a great question and it's kind of a pain, but boys are a little bit more skewed because the quartiles are not, be careful, are not the same distance. Excellent. Which group generally did better on the test? Well, generally would be denoted by the median. So we need to look at the median right here. Boys have a higher median, so the only two answers would be ones involving the median, and the answer would be boys generally did better because of their median. Going here to the next question, we have a time plot, and we will use JMP for this. So let's go ahead and take the data and make tab delimited copy. We'll go over to JMP, open up a new data table, and in this instance you just want to edit, paste. I don't believe there's any column name. On Macs you will see this happen. I don't know why, but it analyzes just fine. So let's go to Analyze, and we want to go to Graph and Overlay Plot. I'm in Graph, Overlay Plot. One problem you'll see with this time plot is with the extra spaces, which you could eliminate. It's just going to put a little bit of room between them. But we can still look at the general flow of the data. So here is our time plot. Now, let's go ahead and connect through missing. Well, it just kind of jitters about here. But we do see it starts out kind of low, goes high, gives us a good general shape of what's going on. Going into JMP, we went to Graph, Overlay Plot. So let's go back to the data here. One thing you can do to get this question correct is to read from the left to the right. If you notice, I have 1, 2, 0, 6, 6. So in other words, you don't even have to use JMP at this point. But if you notice, right here we have 1, 2, 0, 6, 6. This one is correct, and this one also appears to be correct, and this one right over here might have some sort of error. Zooming in, we can see. We have, nope, it is not correct. Let's look at the other one real quick. 1, 2, 0, 6, 6. So the two that look to be correct on mine are A and C. 1, 2, 0, 6, 6. That follows the pattern. So you can do this without JMP. It's nice to know how to use JMP though. It makes things a lot easier. You can have your data side by side or be looking at the numbers. Now, a lot of people get mixed up on this problem because they say, wait, A and C are identical. Well, with that in mind, you just have to look for the right scale. It goes from 1940 to 2002, and that is the correct answer. One last thing to state about this. You can trick the question. If you find the two graphs that are similar, A and C, and then you find the one with the right scale, you'll generally be correct. But make sure you know what a time plot is. It could be important. Summarize what you see. What does the time plot show? Well, it doesn't really do much. This one might be a general increase. I would say it's remained fairly steady through the given years. It hasn't been generally increasing or decreasing. On mine, it's been fairly steady. There you go. Feel free to email me if you have questions.